Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called kinematics and dynamics of machinery. In the previous videos, we have discussed so far. In this unit, we have discussed about the friction in various applications, that is friction in screw threads, friction in clutches, friction in rolling components. Now we are going to see the friction in the ropes also. In the last videos we have seen in friction in belt also. Now we are going to discuss mainly in ropes. We will see one by one. This slide give a glimpse of a syllabus already we discussed in the previous slides. In this we are going to see about rope drives. Rope drives are operate successfully when the pulleys are about 60 meter apart, while the wire ropes are used when the pulley are up to 150 meters apart. Whenever the large distance is needed, we preferred these wire ropes. Then advantages, we can get some advantages in this. They give smooth and steady and quiet service. They are little affected by outdoor conditions. The shaft may be out of strict alignment. The power may be taken off in any direction and in fractional parts of the whole amount. They give high mechanical efficiency. The efficiency will be more when you are using rope drives. Then we are having the formula. Already we discussed in belt drive. We have the formula 2.3 log of, that is T1 by T2 equal to simply mu theta we will be using. For rope drives, we will be using cosecant beta. That only changes we have to use in this. So this is the formula that is shown in the slide. Based on the formula, we have this problem. Pulley used to transmit power by means of ropes has a diameter of 3.6 meters and has 15 grooves of 45-degree angle. Angle of contact is 170 degree and the coefficient of friction between the ropes and the groove sides is 0.28. Maximum possible tension in the rope is 960 Newton and the mass of the rope is 1.5 kg per meter length. Determine the speed of the pulley in RPM and the power transmitted if the condition of maximum power prevail. From this problem, we are going to gather the given data first of all. What are the given data means D equal to 3.6 meter, N equal to 15. We have to take 45 degree as 2 beta. Therefore, beta equal to half of that value, that is 22.5 degree. Then theta is given as 170 degree. Convert into radians, multiply with pi by 180. Finally, you will get 2.967 radians. Mu equal to 0.28 and T equal to 960 Newton. M equal to 1.5 kilogram per meter. Then using the formula, maximum power, the speed of the pulley is nothing but square root of T by 3 meters, 960 divided by 3 into 1.5, finally you will get 14.6 meter per second. Then using the speed of the pulley formula, pi d n by 60, by that we can find out the n value as 76.8 RPM. Power transmitted formula, maximum power, we have this formula, Tc is equal to T by 3, that is 960 by 3, that is 320 Newton. Tension in the tight side of the rope, that is nothing but T1 equal to T minus Tc. Therefore, we are subtracting 960 with 320, we are getting 640 Newton. Then using the relationship that I already told, wire rope, we are having the formula 2.3 log of T1 by T2 equal to mu theta cosecant beta. Using 22.5 for beta, then apply in the formula, you will get T1 by T2 equal to 8.78. Finally, cross multiplying with T1, then you will get T2 value 73 Newton. Power transmitted P equal to, this formula already we have used so many times in the previous friction problems. T1 minus T2 into V into N. This number of ropes, how much we are using, that is 15, should be counted here. That also included in the formula. By that you are getting 173 watts, that is 124 kilowatts. Wire ropes. When a large amount of power is to be transmitted over a large distances from one pulley to another, when the pulley is up to 150 meters, whenever the pulley is more distance, for example 150 meters means, at the time this wire ropes are preferred. These wire ropes run on the grooved pulleys, but they rest on the bottom of the grooves and are not wedged between the sides of the groove. On the bottom of the groove only, it has the rest over it. It has various advantages. These are lighter in weight, already aware of that. because wire ropes having a very light weight. These offer silent operation, very mild operation only we can prefer this. These can withstand the shock loads. These are more reliable. These are more durable. They do not fail suddenly. The efficiency will be very high and the cost is low. Classification of wire ropes: cross or regular lay ropes. So in these types of ropes, the direction of twist of wires in the strands is opposite to the direction of the twist of the strands. So that will be opposite. That is called cross. By the meaning, it is crosswise. Parallel means direction of twist of the wires in the strands is same as that in the direction of strands in the rope, but that is crossed together, opposite to the direction. This is parallel one. These ropes having better bearing surface, but it is harder to splice and twist more easily when loaded. These ropes are more flexible and resist wear more effectively. So it can resist the wear more. Then composite laid ropes. In these types of rope, the wire is where the two adjacent strands are twisted in the opposite direction. So it will be twisted in the opposite direction. Then based on that, another one problem we are going to discuss, the chain drive. Chain drive, one of the major application mechanical industries. Chain drive is used for the reduction of speed from 240 rpm to 120 rpm. The number of teeth on the driving sprocket is 20. Find the number of teeth on the driven sprocket. If the pitch circle diameter on the driven sprocket is 600 millimeters and the center to center distance between the two sprockets is 800 mm, determine the pitch and the length of the chain. First, you have to gather the given data. N1 240 rpm, N2 120 rpm, T1 20, T2 600 mm, that is R2 is 300 mm, X is equal to 800 mm, that is 0.8 meter. Then using the formula, the ratio relationship we are having N1 T1 equal to N2 T2, by using that relationship, we can get the value of T2. T2 equal to 240 into 20 by 120. That you will get 40. Then again using the formula, uh, the pitch circle radius of the driven sprocket R2 is equal to P by 2 cosecant 180 by T2. By using the formula, we will get 6.37 P. By that we can find P. By dividing with 6.37, you will get 47.1 millimeters. Length of the chain. By that we are using the first formula, pitch circle radius of the driving sprocket P by 2 cosecant 180 by T1. By using the formula, we will get 150.5 millimeter. X is equal to MP. M equal to X by P. That is 800 by 41.1, 16.985. By simply calculating, substituting the values, you will get the answers. That's all. We have to remember the formulas. That's only thing. Multiplying the factor, that is important one. We are considering the factor in this. K equal to T1 by 2 plus 2 meter. Sorry, not 2 meter, 2m. That is module. By that we are using that one. Then you have the relationship. Substituting all the values in that formula, we will get 64.56, approximately 65. Chain of the length is nothing but you have to multiply with the factor, multiplying factor, that is K, 65 multiplied with 47.1. Finally, you get the value 3061.5 mm in meter, 3.0615 meters. Then various industrial application we have to look on into that slide. We are aware of that various industrial application, that is belt and rope drives in textile industries. Belt and rope drives in textile industries. Then in agriculture also we are using this type of wire ropes. Then V-belt drive are used in automobile to drive the accessories. Everybody aware of that. And the automobile is occupy the major importance. Then helicopter transmission system, that is the clutch. Lathe machine, the basic operation. In the lathe machine we can see this without belt without possible to run the machine. It's very important application. So This is the reference link which I used for taking the contents to prepare these slides. Kindly go through this reference also. Kindly go through the formulas before doing the problems. Thank you students for your kind attention. Successfully we have completed unit 3 friction of 4 parts. Already we have seen the 3 parts and the final part is also over. Kindly go through each and everything. Kindly remember the formulas before doing the problems. Kindly subscribe and share this video to your friends. Thank you.